So what we first of all need to think of is, well, we've got the relative atomic mass. So we're going to start off by identifying what are the things that we are given and what do we want. Calculate the maximum mass of iron 3 chloride. So this one here, this one is the target. So I'm going to highlight that in green, if it lets me. Yeah, so this is my target, okay? That can produce, and we've got the known substance which will higher in yellow. Okay, so now we look at the balanced equation, and great news is it's 1-to-1. So for every 2 moles of iron, we're going to get 2 moles of iron chloride. So in terms of moles, the ratio is 1-to-1. All right. If I had 2 moles of iron, I could get 2 moles of iron chloride. Yeah? Happy with that? So we're not interested in this bit here because that it's not asking us to do anything with chlorine. So essentially, we are assuming that we have excess chlorine. Okay. Now, if you mean the 3 here, then that 3 will be taken care of when we calculate the mass. But in terms of moles for a start, if we had however many moles of this, we would have the same amount of moles as that. Now we just need to work out, well, how many. I know that because that's what the balanced equations tells me. That's what that means. So if I think about another example, so let's just. Oh, come on. How come I can't? Okay. So if I just get just a standard equation like C plus O2 goes to CO2, what that equation means is that 1 mole, if I had 1 mole of carbon and I had 1 mole of oxygen, I could produce 1 mole of carbon dioxide. So what this equation is telling me here, and I'll write it in a comment as well, is if I had 2 moles of iron and 3 moles of chlorine, that's not chlorine, I could produce 2 moles of iron chloride. That's what it's telling me. First of all, it gets a bit tricky when we talk about molecules in this situation because it's an ionic compound, and ionic compounds don't form molecules. So the thing that we're making is an ionic compound, so it doesn't form a molecule. But so in my example over here, that is a molecule. So we can, if we like, say that 1 atom would, every 1 atom would react with 1 molecule of oxygen to produce 1 molecule of carbon dioxide. But when we are doing moles, exactly the same thing can be said about moles. So although it's true that 1 atom of carbon would react with 1 molecule of oxygen to produce 1 molecule of carbon dioxide, I can take that entire equation and swap the word atom and molecules for just moles. So let's write the equation. Let's write the sentence out. So just to recap, what is a mole? A mole is just 6.02 times 10 to the 23 atoms or molecules of something. So a mole of oxygen would be that many oxygen molecules, and a mole of carbon would be that many carbon atoms. So I know. So basically, let's think about it in a more simple example. If I'm saying, so let's start off then. This is going to take just a minute or so just to explain why. So first of all, I'll tell you what the thing is that I'm claiming, and then I'll explain why that's true. So the one on the right, it says 1 atom of carbon reacts with 1 molecule of oxygen to produce 1 molecule of carbon dioxide. Now we have no problems with that. We're used to that, and we can see it visually because we can just see one atom combining together. We know what the molecules look like. We can draw it out with the circles and everything. That's not a problem. What I'm claiming is that I can take that same sentence, and instead of writing atom, I can write mole, and I'm going to explain why in a moment. But I can say mole instead of saying molecule there. I can say mole, and I would have to say mole here as well. So first of all, that is, so we've got a couple of options here. We can just go, okay, fine, I trust you. But I think you're doing the right thing in understanding why. We need to understand why. If we're going to get the higher marks, we need to understand why is that the case. So the reason why is, yeah. Okay, so let's just make these bold as well. So so we need to understand why that is the case. Well, let's say that, for example, so we'll say that, yeah, let's put some numbers down here. So we'll say we'll make a little table: carbon, O2, and CO2. And so, oops. So basically, if I had one of those and one of those, I'd get one of those. Happy? So if I had 10 of those and 10 of those, we'd get 10 of those, wouldn't we? Yeah. If I had 100 of those and 100 of those, we'd get 100 of those, right? You can imagine each one of these, 100 happening 100 times, we're all bonding together and making it like that. If we had 6.02 times 10 to the 23 of those, and you can see where I might be going with this, 6.02 times 10 to 23 of those, and 6.02 times 10 to 23 of those, well, we would get 6.02 times 10 to the 23 carbon CO2 molecules. So I'm not saying this equation doesn't tell me how many I've got. It's saying what would happen if I had whatever. Exactly. So actually in this case, it's actually 2 times that. So, however, it's also 2 times that over there. So the ratio is 2 to 2 in terms of atoms, or in terms of molecules, or in terms of moles. It's the same. So the ratio. So if we could start off with 2 atoms, or we could just times that 2 by that massive, great big number, and we've got equivalent of 2 moles, haven't we then? So 2 times 6 times 202 times 10 to 23 would be 2 moles. So in other words, 2 moles of that could react with 3 moles of that to produce 2 moles of this. Okay, so now we understand that, then we can say the sentence that 2 moles of Fe, which is our known substance, could produce. This is, by the way, assuming we have enough chlorine, right? But we have to assume that because they've not told us anything. So far, I'm assuming we have enough chlorine, but it's possible that we won't. But I think we will. 2 moles of Fe could produce 2 moles of Fe, so iron chloride. Yeah. So in other words, 1 mole of iron could produce 1 mole of iron chloride, couldn't it? Or 20 moles of iron could produce 20 moles of iron chloride. The point is, it's 1 to 1, right? So the next thing, now we can say that that's just the balanced equation. It wouldn't matter how much iron chloride we actually have. That's beside the point. Okay. So the next thing we want to know is, well, how many, we know if I had 1 mole, I could produce 1 mole of the other, but how many moles do I have? So to find that out, but let's make sure we understand the reasons why as well, because if we know that a molar mass simply means the mass of 1 mole, right? Mass of 1 mole. Because you took great efforts to understand all that stuff over there, so we need to make sure we understand this stuff over here as well, right? So molar mass is the mass of 1 mole. So we want to now know, well, why is it, if the mass of 1 mole is that, so that's the molar mass. So in other words, 1 mole times the molar mass is going to equal to the mass, isn't it? Because if I had 1 mole, if I had 2 moles, so basically the mass is going to equal to the number of moles multiplied by the mass of each mole. If I had 2 moles, it'd be twice as much as the molar mass, wouldn't it? So you do need to know this. Molar mass is what you just called for a second ago, relative atomic mass. Relative atomic mass is the same. You're using the right word. It's just a term. So we can say relative atomic mass or relative formula mass, but it's also the same as a molar mass because it means the mass of 1 mole. Well, what you just said is fine, but they may use the word molar mass. So you need to know both of them. So don't think too much about how much you've got to remember. So once you understand that the molar mass simply means the mass of 1 mole, and it's also can be worked out by the relative atomic mass or the relative formula mass, then we can put that into a triangle and use the triangle to rearrange the formula. So we've got the mass. It's 11.2 grams. That's the known substance. So I'll just highlight that. That's our known substance there of iron. So we get the first thing we're going to do then is calculate how many moles that is. So we got to think to ourselves, we're just working out the number of moles, and the molar mass of iron is here, 56. So we don't have to, we're not interested in the reaction at the moment. We're just asking the question, how many moles of iron do I have? So the number of moles moles is going to be 11.2 divided by 56, and that would give us the number of moles. Say again? 0. Yeah, that looks right. So 0.2 moles. Yeah. So what we're saying here is 11.2 grams. Well, that's the amount of iron in terms of mass, and now this is the amount of iron in terms of moles. So we've converted it. So now we know how many moles of iron we do have. Not so long ago, we said that if we had 2 moles of iron, we could produce 2 moles of iron chloride, which meant if we had 1 mole of iron, we could produce 1 mole of iron chloride. And I said, well, basically the point is we have 1 to 1. So whatever amount of moles of iron we've got, we're going to produce that many moles of iron chloride. So how many moles of iron chloride are we going to produce if we had that many grams of iron? Right, because it's what in terms of the moles, the ratio is 1 to 1. So we've got 0.2 moles of iron. So why do we not multiply that by 2? Why do we multiply this by 3? Well, basically what I calculated earlier on was the moles of Fe. I didn't calculate the moles of 2Fe. I calculated moles of Fe, moles of iron. Now what I'm doing is I'm calculating the moles of FeCl3. So I have to, because it's a compound, the numbers, basically, if you want to, a shortcut is, yeah. Oh yes, yes, yeah. Oh, sorry, I'm not looking at this 3. I'm looking at that 3. Yeah, I see what you mean. Yeah. So we know it's zero point 0.2 moles. So the mass is going to be equal to the moles times the molar mass. So let's just work out the molar mass of iron chloride. It's going to be 56 plus 3 times 35.5. So that's equal to 162.5. So that's the yeah. So wait, the molar mass is, yeah, that's the molar mass. Good. I've just worked out there of the iron chloride, and so that's how many. That's the mass of 1 mole. Now I've got 0.2 moles, so I'm going to times that by 0.2, and yeah,